boys and girls, so here we are again doing some practical work today. Some of these things we may have done in class a little bit briefly, but I decided we're going to redo them because I know some of you weren't in class and there were some classes that missed it. So we're going to go through these practical experiments. What you must have with you is your textbook. Please make sure you've got it and some paper to write on, because as we go through these experiments you've got to write down the answers. You jot them down on the rough paper, and then you're going to take your workbook and you're going to write them out in lovely, good English sentences. Okay, so we are looking at mixtures, and you know that last lesson we spoke about what is a mixture, and we said a mixture is where we put two or more things together and we combine them. We also spoke about the phases of matter. We said there are solids and liquids and gases, and each one has some specific characteristics. So you're going to see today we are going to mix solids with solids, we're going to mix solids with liquids, and we're going to mix liquids with liquids. So bear that in mind of the different phases that we are working with in order to make these special mixtures. Right, so let's have a look what we've got on the table here. So the first thing we've got here are some coins. There are some 50-cent coins and there are some 2 Rand coins. Now this is a mixture because according to our definition it says it's 2 or more things that are put together. So if we put them all in one container, has anything happened to the 50-cent coins? Do they look different? Is there anything different with the 2 Rand coins? No, of course not. Nothing has happened to change them. They are all there and you can see them and you can identify them. So it's clear nothing has happened in this mixture of coins. Right, let's look at the next one. We have 2 different types of beans here, or seeds. Here are peanuts and these are black beans. So we can look at them and we can identify them very easily in their 2 containers. So we are now going to make a mixture and we're going to mix them. I'm going to give them a little shake, mix them up a little bit, put them back. And now we've got, remember that nice word, homogeneous. We have homogeneous. In other words, it looks the same. If I were to take a few from here or a few from there, it would be the same. That's what homogeneous means. Right, so let's look at question number 2. It says we must mix the peanuts and dried beans, and what happens to the peanuts? Did they change since we mixed them? Of course not. What happened to the dried beans? Have they changed in any way? Can you identify the peanuts? Can you see the beans? Right, so there we've got another mixture, solids with solids. Let's go to something a little finer. I have some sugar and I have some tea. If we look at the tea, number 3, it says we must mix the 2 together. So I'm going to mix the tea with the sugar. Yeah. The tea came out of a tea bag. I'm just going to mix it quickly with this spatula, or a scientific spoon. We can call them any of those names. Right, now look at that. Does that look like tea? No. Can we identify the tea? Well, we could say all the dark stuff is tea, isn't it so? And the lighter stuff is the sugar. What has happened to the sugar? Has it changed? I don't think so. It's still granular and it's still there. Can you see the tea leaves? Has anything happened to them? They haven't changed in any way either. It's a mixture of a solid and a solid, but there's no change that has happened to either of the components. Right, now, don't ask if you can have some, but I know you want them. Right, what have we got here? Some sweeties. We've got some worms and we've got some licorice, all sorts. What are your favorites? Can you identify them? Which one would you like? These are my favorites. The worms, I must say, are pretty close. Right, so question number 4 says, can you select the ones you like the most? Oh, I could quite quickly. These we always fight over in my family because we all like these little ones. Right, it also says, does it taste like the other sweets? So if I'm going to eat one of these, does it taste like the worm or these other, I don't know what they call them, but little mixtures? Or there's even one tiny mo there. Right, so does it taste like that? No, it doesn't. It's got its same ordinary taste that it always would have. Just because they've been mixed in a group, it hasn't changed the flavor. Number 5 says we must investigate the properties of salt and sand. So I have some salt and I have some sand. The first thing we need to do is to have a look at it through the microscope, or through not a microscope, this is a magnifying glass. And if we have a look at that, we can see the grains of sand are small and grainy. I don't know what other word we should use for that. And if we look at the salt, we can see it's white. They're all the same. They're also grainy. If you have a magnifying glass, have a look at salt, because there's something very special. Because salt is made of crystals, you'll see that all the salt crystals are actually square. And we can identify things just by their shape. Well, they're kind of square, more rectangular type of shape, but you can see their corners. Right, so it tells us now we must mix the salt into the sand, and once again we'll mix them up and see what kind of a mixture we get here, and then we're going to have a look at it again with the magnifying glass. Today it wants to be a microscope. Well, it's a pity we couldn't look at it under a microscope, because that would be really cool. Right, I think we've got a good homogeneous mixture there. So if we look at that with the magnifying glass, what can we see? Can we identify the salt and the sand? Well, I don't think I can, you know. I think that the salt and the sand have kind of mixed. If you asked me to sort these into salt and sandy groups, I would have a problem. I wouldn't know which was salt and which was sand. Nothing has happened to the salt, it's just mixed up with the sand. They don't look much different. Right, so those are our solids and solids that we have mixed. If you are going with me in your textbook, you should now be on page 64, right at the top, and it says mixtures of solids and liquids. So for that, I have some water and I have some of these powdered cool drinks. So yum, we're going to pour some of this into that thing. Please note that our water, apart from it being wet, is clear. So now I'm going to throw in a little bit of cold drink powder or Kool-Aid powder, and let's see what happens. Let's just have a look at this. So this is also gritty or grainy, something like the salt. And if I'm going to tip it in there, and I'm going to give it a couple of stirs. Oh, things are happening here. The water has become orange. There's some grains, they sank to the bottom, but I'm stirring them. Now we've got a lovely homogeneous mixture. What has happened to the cool drink crystals? Well, we can't see them anymore, can we? They have dissolved. They have disappeared. Remember what we spoke about when we spoke about liquids? Those molecules that are packed closely together, but there are spaces between them? Well, now the grains of the colorant and the sugar and the flavorant of the cool drink have gone in between all those little molecules, and now we can just see this is a nice clear mixture, and I'm sure that's going to taste very nice. Right, so that's now mixing a solid with a liquid. Now we're going to do some different ones, and this is activity 3 in your textbooks. So get your book ready. I have asked you that you draw the tables, so make sure you've got your tables drawn before you proceed. Okay, so what have we got here to test liquids with solids? I just have 80 milliliters of water. I know your textbook says 100, but my beakers were a little bit small. So they've all got 80 milliliters of liquid. The last one has milk and the others have water. So in your textbook it tells us we must put a teaspoonful of sand into the first one, and you need to watch what happens as I pour it in. Here it goes. Did you see that? It sank to the bottom. I'm going to give it a little stir. There's still a few floating bits on the top, but majority of the water, the sand has gone straight to the bottom, and the top water is now clear. And, well, have they mixed? Have they disappeared? Can we identify the different components, the solid and the liquid components? Well, you need to fill that in the table in your book. Number 2, it tells us we must put a teaspoonful of crushed chalk. So I took some chalk and I crushed it. Let me put it here so you can see with my little pestle and mortar. There's the chalk, and I've made a nice powder of it. And now I'm going to put that spoonful of crushed chalk. And are you watching? Because this is quite something to see. Look carefully, and gadum, in it goes. Look, looks like rain. And there's some that just floats on the top. What has happened? Still dripping down. I'm going to give it a quick stir. Let's see if we can dissolve the chalk into the water. Oh, it's gone beautifully cloudy now. But what is happening? Let's watch. We'll have to leave it for a few minutes, and we'll go on with the next one, and then we'll come back and have another peek at what's happened. So number 3, it says I must take a spoonful of curry powder. So I've taken this curry powder out of my cupboard, and we're going to put a spoonful of curry powder into number 3. Are you watching? In it goes. Oh wow, what is happening? Look how beautiful that is. Slowly but surely the little pieces of curry are dropping to the bottom. Isn't that beautiful? Quite different to the sand. Shall we give it a stir? Yo! Right, that water has turned curry color. We have a few things floating on the top, but it looks like most of it has gone to the bottom. Okay, number 4. We've got the milk in the glass. It says add a teaspoon of grated cheese. So there's a little bit of grated cheese. And let's see what happens. Ding, 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 ding. Oh, what is happening here? It's just stuck on the top. I'm going to give it a stir. Oh, doesn't look like it wants to go down. The cheese is floating. Can we see the cheese? Yes, we can. Has it done anything to the milk? Milk still is quite cloudy. The cheese looks the same. I can identify the pieces of cheese floating on the top. Right, your textbook says we must leave them for 2 minutes. I think we have left the sand for 2 minutes. We can have a look now what has happened here at number 1. Can you see the water is beautifully clear above the sand? This one, the one with the chalk, the water is tiny bit cloudy, but there's a nice big thick precipitate that's formed on the bottom. Curry powder, we're going to give it a little while and we'll see what happens with that. But it looks to me like it's quite collected at the bottom and the top is getting lighter and lighter. And nothing has changed with the milk. We've still got the cheese floating on the top. Well, let's leave that for a few minutes. We've got another table to fill in, the one at the top, in which you are going to summarize in a few minutes. But in the meantime, we're now going to do a mixture of liquids and liquids. I don't have any cordial cool drink. I'm sure you've all used Oros and mixed it with water. So it tells us here, and there's a little picture of it in your book on page 65. If you mixed the liquid Oros with some water, the concentrate with the water, then you see that nothing happens. It just becomes a new color. It becomes a little paler with the water when the cordial is added to it. Right, so here we've got the oil in the measuring cylinder, and now I'm going to put the water in. Are you watching? Oh, so closely. Watch it. I'm going to fill the same amount of water as I have oil in it. Oh, watch what the water is doing. Looks like those lamps that you make. Right, so there we've got it. But what is happening here? Who put bubbles in? Not me, I put water in. I'm going to give them a little stir. Let's see now what happens. Wow, look at that. But there's something interesting that's happening here now. What is it? Are they mixing? Can you identify the oil? Can you identify the water? By the way, where did we put the oil? At the top or the bottom? So what is busy happening? Here, the water is heavier than the oil. So the water has displaced, that's a good word, displaced the position of the oil. So the water has gone to the bottom and the oil is busy coming up to the top. So you can see these looks like bubbles. They're not really, they're globs of water that are surrounded with oil. And as they collect together, so they will get heavier and go to the bottom, and the oil, which is lighter than water, is going to rise up. So if we leave this for a day, you will see that it will separate beautifully back into the oil at the top and the water at the bottom. The water has displaced the position of the oil. So can we say that these two liquids have mixed? No, we can't. They haven't mixed. They don't like to mix. Not oil and water. We call this an emulsion. You'll see on your notes I've given you, when you get your memo, that I've explained to you what an emulsion is. It says that you've got two liquids that are mixed, and the one makes little bubbles or droplets in between the other one. And, oh, big things are happening now. The oil is going up. The water is coming down. Right, so an emulsion is where there are little droplets of one substance which mixes into the other, but it does not make, it does not become a different and new substance. They are there and now they're going to separate. So we are busy watching it separate right now. What we are wanting to do now is to see if we can separate these particles. So you'll see in your book on page 65, it says separating mixtures. So there are 5 methods that we need to use to separate them. We call them physical methods. That means you use your hands. You've got to do something to physically separate them. So the most typical one is called sieving. And I'm sure you'll recognize a sieve like this. It's got a grid, and the grid has tiny little holes, and anything that is smaller will go through, and anything that is bigger will remain behind. So I'm going to put that down as a background, and here you can see I've got like these bags they put the veggies in. So you can see the size of that grid is much bigger than the sieve. And this would work very nice if you wanted to separate, say, marbles from sand or something like that. So the sand would go through nicely, and the marbles, which are bigger than the size of this grid, will go through there. So that would have been a very useful size to use. All right, then I've got a piece of material which is now finer than the sieve. Those grids are very small. You can only just see the color through this one. And that would also be very useful to separate maybe something more liquid than solid from the solid, like sand with water. So maybe for our first sample that we did yesterday, we could have, last time, we could have used the sample there. But we can also use scientific stuff. This is scientific filter paper. So this filter paper comes as big circles. It is very expensive because this, we call them Whatman #1 circles. They have got a grid, even though it's not like a coffee filter where the filter is of any size. These are very specific size grid that's inside the paper. And you have to learn to fold it properly. So watch carefully. Quite simply, you fold it in half, and then you fold it in half again until you have got a quarter circle, and then we take 3. Can you see? We take 1, 2, 3 on one side and 1 on the other, and now we get a nice little filter. And then I take a scientific funnel and we'll pop it into the funnel, and now we can pour our sample in there. I've got a beaker and we'll just stand it in the beaker, and then we can separate anything that is perhaps more finer than sand, maybe something like flour or our chalk sample we could separate quite easily by putting it into filter paper. So the ways that we would separate things: we can filter them, we can sieve them. Next word that you need to know is hand sorting. So again, using our physical hands, and we can just separate things into different groups. And so we're going to do that with got peanuts and beans. So we'll put them in here. It's a homogeneous mixture. We want to separate so it's not homogeneous any longer. So once again, we'll just separate the little black beans from the peanuts, and in no time at all, we will have them separated. Few more peanuts to that side, slipping around here. There we go. So now we've got a group of peanuts and a group of raisins. Hand sorting. Right, what else did we use? We have our sweeties. Apart from being able to choose our favorite sweets, we could sort it into the shapes of them, or the types of them, or the colors of them. So we would just have to decide what our sorting criteria is, so that we've got them all in their little groups. But hand sorting is what we are doing. Hand sorting. Sorting it physically. That means using your hands or some mechanical method. Right. Okay, so for the money, we can separate the money. We could just look at the different colors. And so we could easily separate the brown ones from the silverish ones. And there we go. I've got them all there. Of course, in the banks, they use weight. They don't look at the colors and the shapes of them. They just look at the weight, and they will separate them very quickly by weighing them, and they know exactly how much. So our money is always made to a specific weight. Each coin has got its own unique weight. So that's separating by hand. Well, what about something like this? This is the mixture of sand and salt. We looked at it with a magnifying glass, and we saw that it's a homogeneous mixture, and we couldn't really identify the separate particles. So hand sorting would be just about an impossibility. I wouldn't like to do that. Maybe we should use that as a discipline punishment, huh? But nevertheless, we can't separate these very easily. I wonder if you can think of a way to do it. I can think that somebody has come up with a really smart plan, because sand is insoluble, but salt is soluble. That means it can dissolve in water. So how about we just put water in there, and we dissolve it, and then we bring along our little filter, and we can filter it, and boom, we will have the salty water on the one side, and we will have the sand on the other side, and within a few minutes we can leave the water to evaporate off. Not a few minutes, within a few days, and we would have the salt crystals forming at the bottom of that one. So that would be quite an easy way of separating the salt from the sand. We could do the same with the tea. We could do the tea and the sugar. We could just separate them by dissolving the sugar. But here we can see the two different particles quite a bit easier. Right, so those are our solids mixed with solids. But now we want to have a quick look at our liquids, because these we will be able to use a different of separating them. And this one is called settling. So I hope you've had a good look at how they have settled beautifully. The sand is at the bottom, the water is clear, the chalk is at the bottom, the supernatant, that's the water above it, is clear. The curry powder, the water is yellow, but the curry is at the bottom. And the milk and the cheese, well, look at that. The cheese is still at the top. Can you see it is still there? It is floating. So we have settling, which is one of the methods that we can separate things. And then we have another thing which is called decanting. And decanting says I can pour the top layer off. So decanting would work very nicely with this sand and water, because it would be able to pour off quite easily. So I'm going to do that right now. I'm just going to decant very slowly. Try not to let some of the sand has already just started to run down there, but now we can take it off. And so soon we'll be able to separate or settle and decant the sand particles from the water particles. So there we are. We've got the sand in there. I don't know if you can see that nicely in the camera. And there is the water. So we could do the same with the chalk. We could probably do the same with the curry powder. But man, we won't be able to do this. With the milk, we're going to have to do a filter. The jar, and then I'm going to put this cloth with the larger holes in it. And then we are going to just pour the milk and the cheese into the cloth. Oh, I can hear it running through. Whoa, catching all the cheese now. There we go. So there we've got the cheese. And I'll show you the milk at the bottom. There's all the milk back. So we've managed to separate those as well. Okay, so let's just recap. So there are these 5 ways that we can separate solids from solids or solids from liquids. So what have we got? We have sieving, where we use a grid. We have hand sorting, where you use your hand. We have filtering, where we need a scientific filter or some filter material. And then settling, where we just let the things settle down or sink down. And last one, decanting. And remember, the settling and the decanting often go together. Right, so how would we separate the oil from the water? What method do you think would be the best? Because that is liquid from liquid. Yes, I think you've got it. Of course we would decant. Remember, the oil came to the top. We started with it at the bottom, but the oil is now at the top. And the water has sunk to the bottom. And we could just decant the oil off, and we'd have the water left separate. And look how beautifully they have separated, nice and clearly. So we can easily decant that without too many troubles. Right, so boys and girls, that is it as far as mixtures go and separating of mixtures.